All right, so today what we're going to teach about is shorthand notation. Now, some of you guys are going to be very upset with us, when you get done with this particular lesson, because you're going to say, Mr. Kirby, why did you make me do all that longhand stuff, right? Well, there was a process and a reason for it, and so I'm going to go ahead and teach the shorthand way now. So, shorthand notation. Well, in order to teach you shorthand notation, I'm going to do a quick one in longhand notation. So, the element I'm going to choose is I'm going to choose copper. So, when I look at the periodic table and I find copper, I would note that copper has 29 electrons. So, 29 electrons. And the longhand would be this. So, we start here, right? So, 1s2. Then, like a typewriter, 2s2. Then, 2p6, 3s2, 3p6, 4s2, 3b. Now I gotta get to 29, right? So 2, 4, 10, 12, 18, 20. 10 will fit in a D, but I don't need them all. So it's 9. Now, yesterday you learned about I can take a look at this 3D9 thing, right? And I can go find that on the periodic table. And I told you it's kind of like a cheat method. So we come over here. We have our blocks, right? We have our S block, not a coincidence, 2 electrons, S2. We have our P block here, right? P6, not a coincidence that there are 6 electrons or 6 elements. D block, 10 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And then, likewise, F14. Remember, you got that weird, quirky thing, right, where lanthanum and actinium are actually here, and lutetium and lawrencium are here. So when I look at this, all right, the only thing I got to remember with this sheet method is that there is a 3D, right? If we go over to this chart right here, you would see right here we have 3D, right? Well, if you come over here and you look for 3D area, there's nothing there. That's because all of these, you have to say, are shifted up 1. So this ends up being 3D, 4D, 5D, and 6D. And that makes sense over on that chart too as well, because there's no 7D. It does not exist. So again, 3D, 4D, 5D, and 6D. So 3D9 is what we want to get to. So 3D1, 3D2, 3D3, D4, D5, D6, D7, D8, D9. Yay, copper matches copper. Now it's time to teach you, though, something called shorthand, or it's also sometimes called noble gas notation. Here is why. What you do is you find the element, so this is copper, and you go find the noble gas in the row directly above it. So you're in row 4, right, even though this is 3D. You go find the noble gas in the row directly above it, and it is argon. Now, if we were to do argon's electron configuration, it has 18 electrons, right? So it would be 1s2, 2s2, 2p6, 3s2, and 3p6. Right? So that's the longhand of argon. Now here's why I'm showing you that. What we can end up doing is if you look at this and this, they're exactly the same. So here's what shorthand notation says. Well, since argon's last thing is 3p6, what we can do is this. We can put where 3p6 is, we can put in brackets argon. And that would have 18 electrons in it, right? Then all you have to do is start with the next thing, which is 4s2 and 3d9. 18, 20, 29. 29. So the cool thing is you get to skip all of that. Because argon stands for this. And that's noble gas, or shorthand notation. Let's do another one together. And I'm right on your sheets, so the nice thing for you guys is I'm doing the first examples right out of your packet. So the next one says iodine. So when I look at iodine, I know that it has, I'm looking over, 53 electrons. I could even cheat too with iodine, right? I could look at it, I could say, okay, iodine, it's in P block. So I could cheat and say the last thing should be 5, P1, P2, P3, P4, P5. So it's going to end P5, P5. Well, here's how I do this shorthand. I say 53 is here. What is the noble gas directly in the row above it? Well, directly above it is krypton, right? So the first thing I should write is krypton. Now, that means I get to skip the first 36 electrons. Now you might say, why is that? It's because it's element number 36. There are 36 electrons we've already placed by putting krypton. So, what we do is we get to start where krypton is. Well, krypton would be 4p6, right? So we get to start with what comes right after 4p6, because this really stands for 4p6 right here. So when we go find this on here, and I've kind of already replaced it right here, 3d10, 4p6 for krypton. Next thing is 5s2. Well, 36 electrons plus 2 is 38. That's not to 53 yet. So we keep going. 4d10. Or there's 10 possible, and I need all 10. 36, 38, 48. How many more do I have to place? I got 5 more to go. So after 4d10, right, comes 5p. It's right here. You can see it. And 6 would fit here, right? But the issue for me is 36, 38, 48. To get to 53, I only need 5 more. 5p5. Now, when you ask yourself, does your answer make sense? Well, it said to you before, 5, P1, P2, P3, P4, P5. Now, there is one thing that could get a little tricky, and let's see if I have one in here. One where it's the noble gas. Can't be your own. Let's go over one. This isn't in your packets. But you cannot be your own shorthand. So let's do argon again. But now I want it shorthand. So argon with 18 electrons, and I want it shorthand. So you go over to argon on the periodic table. You find the noble gas in the row directly above it. That is neon. It has 10 electrons. So you come over here and you write neon. It would have been really awesome, guys, wouldn't it, to just put, AR in parentheses or in brackets and be like, I'm done. Yay. Can't do it. Okay? Cannot be your own shorthand. So neon, and we said that that one was 10 electrons. Well, I got to get to 18. So neon would be found at 2p6. So it'd be right here. So after 2p6, because that's what this stands for, is 2p6. That's neon. After 2p6 comes 3s2. 10 plus 2 is 12. So we got to keep going. 3p, I can fit 6 more. I need all 6. 10, 12, 18. 18. I can go check it. Go find 3p6. 3, p1, p2, p3, p4, p3, 5, p6. And it is indeed argon. And that is shorthand notation.